Good morning, everyone. So let's today talk about another interesting topic. It's going to be a combination of two, three topics. So one, we'll talk about why SLMs are really becoming a very important talking point in the AI landscape. Two, we'll talk about Edge AI. And three, we'll talk about a technical concept which actually has a lot of interlock with the first 2 points. It's called as floating point precision. So now, why are SLMs really becoming significantly spoken in the AI landscape? Now, it's SLM is nothing but small language model by the definition itself, right? So unlike their their bigger cousins, or like what we call as large language models, which are trained on, let's say, humongous data sets and have billions of parameters. SLMs are very small, nimble, precision based models which are trained with limited data sets, and they are not as big like the LLMs that we talk about. So what this means is, since the size is small, what happens is you can actually download them and run on edge devices. When you say edge devices, they're like your laptops, mobiles, tablets, and in some cases, we can even say the local servers that you have in your on-prem ecosystem. So those are all your edge devices that you talk about. So you can download them and actually you can run them. So now the obvious question that comes is, when why would people really think LLM, SLM, and what's the drive towards SLM, right? So if you look at it, there are a couple of parameters or factors that you really need to understand when it comes to LLMs. Most of the LLMs, as are because of their size, are run on data centers which are hosted on cloud providers, and that means that you are constantly interacting between your edge device and your cloud infrastructure where data keeps moving, and that's how you basically are consuming the LLMs. Now this leads into a couple of parameters, factors, right? Like, you are worried about your latency because obviously your speed of execution depends on multiple parameters of your broadband internet and all the available the infrastructure that is available, etc. The second aspect that becomes very important is data privacy, and a lot of questions have started coming in on in this area, right? Where people are worried about how data, when it moves, what's the how are we securing it, and what's the privacy of where this data is getting stored, or even where it is processed. So all these things become important, and in this context is where SLMs came into picture, because if you can run something on prem in or on your own device, obviously these questions that we had when it came to LLMs goes away. So to go to the next level, I think there is you need to start understanding about the floating point as a concept, because that's where I think the crux of all this discussion is about, right? Like, see, net you don't want someone to you don't want to compromise on your performance, you don't want to compromise on your accuracy. So how do you balance this? Like, how do you balance the cost that you'll incur when you are running on or running an LLM, uh, like arbitrage with the accuracy? Like, you don't want to compromise on any angle, right? So this is where you need to understand the point called as floating point precision. So for floating point precision is if I have to really bring it down to very simple example and explain it, how do I do it? So you would have seen terms like FP 16, 32, 20, 128, etc. Right? So floating point precision is it's a like AI models don't always need the highest precision math to give us useful insights. So it's like, let's take the example of a pi, right? Like, the value of a pi is for some people, they'll say 3.14 is more than enough. I can start executing my mathematical calculations based on that. Some might say that, hey, I need more accuracy, so let's use it as 3.14159, or yeah, like five decimals. And some might say, hey, my use case, or I need really high accuracy, so I'll use 3.14159 plus some 7 8 other decimals after that, right? So that could be like the highest precision value, which is FP 128 or around that. But in real life use cases, when you see, right, like do you need, for every use case that you have, do you need the value to be so precise? Do you really need 10 decimals to be really available for you to execute something? Example, take a simple example of your home address, right? Like how many parameters do you need to define a very accurate home address? Certainly you can't just give your house number and say, okay, this is my address. No, like obviously if you give a home number 101, there are millions of houses who that could be 101. But if you give a and the if you give a combination, right, like if you give it like, okay, here is my house number, is here is my building name, here is my society, and maybe my street name, my pin code, and maybe my state where I live. Suddenly what happens is, with this five parameters, you are able to get from an accuracy of say maybe 10%, 20% of finding your right address to around 90, 95%, right? Because that's what happens with this five six parameters. Most of our yeah, like say mail services works. It works seamlessly. In fact, more than 95% accuracy is achieved. Now imagine that someone says that, hey, I want to add more parameters here. Let's say that I want to define my address by 30 parameters. I'll give my east, west, south, north, like say what is my longitude, latitude dimensions. I'll give my reference points of what's the landmarks that are around, what is the wall color. I mean, think about multiple dimensions, right? You keep adding. What will happen by adding those another 25 parameters? Do you think that you're going to significantly improve your accuracy of delivering a mail? Certainly not. Already it is at around 98%. What might actually come out of this additional 25 parameters? All you're going to end up doing is you're going to make your entire processing that much more heavier, slower, and in fact harder to execute and run, right? Because it becomes that much more complex. And that's exactly the point that you need to understand when it comes to floating points. Because just like we don't need FP28 for most AI tasks, we also don't need 100 parameters when five parameters can actually give us the outcome, right? So in short, what happens is smaller, smarter, and more efficient models that can run on edge has actually caught the attention of many people. And this actually is a powerful shift that I'm seeing. I think the proliferation has already started happening. You will see that a lot of AI models, which are SLM models, high precision models, will start running on your phone, your cars. They run on our watches and devices, and all the IoT devices that will be in factories, they will all have SLMs embedded locally, so that they can give the right AI inputs or actions when required. But that doesn't mean that the entire LLM concept goes away, right? So if I have to really look at it with the long term perspective, I see that this might become a hybrid world where there'll be a lot of SLMs running on edge, which we can call it as physical AI. That's another term that's coming up. There might be humanoids, there might be drones, there might be all these IoT devices where we'll see a lot of these SLMs running high precision, customized to the domain, to the task. And what can happen is, as they run, maybe overnight or during their downtime of charging or something, they might transfer all their data sets to over the cloud to the data center. And what happens is big LLMs might consolidate that data. They might do the enhancements, they might do the reinforced learning, they might make the SLMs better. So what happens is with reinforcement, like say reinforcement, fine tuning, RFTs, and supervised fine tuning, all these concepts that we know of can be run on those. The LLMs can actually like fine tune the smaller models, and maybe the next day, who knows, the inputs are back to your SLM, which just now is enhanced version of what it was a day before. And this is the world that might come up, right? Because it's like a constant, like say, action, like run and evolve kind of exercise, and that's where both of them might actually find their own niche spots. So I hope you got a flavor of. I know we spoke a lot, multiple topics we touched here, but I hope you were able to get the connections between how these three major points are coming together. Again, feel free to drop in in the comment section any topic that you would want me to pick up and talk about, because most of the my talks are based on some questions that I get over LinkedIn or some through other channels. So feel free to drop on the comments what areas you want me to talk about. I would be more than happy to take them and explain them as much with and try to give as much clarity as possible in the simplest way. Have a great day. See you soon. Bye.